Peter's the Crazy Cat Lady. Today's lesson is going to be about rewriting radicals as exponents, and that means we have an easier time doing the computations of simplifying our radical. Let's first talk about a radical. Here's a radical. It's a cute little radical. 48 a to the fifth b squared. I'm going to say it's the third root. Now, 3 is our index. It's a very important number. If there is no number sitting on that little shelf, then the index is 2 and we have a square root. The little symbol here that I've written in green, okay, this is the radical. That's what that symbol is. It's the radical. And what sits up underneath the radical, all of this, is called the radicand. Okay, recap. Index tells me how many of something that is inside the radical, that is in the radicand, that's a factor of the radicand, how many of those factors I have to get one of those factors on the outside of the radical. Now, let's look at an example. Let's say I have the cubed root of 48 a to the fifth b squared. Now, first thing I'm going to do is I'm going to look at, this is real simplifying of a radical. Let's look at it in terms of prime numbers. 48 is really 2 cubed times 3, I think, yes, and then I have a to the fifth b squared. Now, to rewrite, if I was going to simplify this, I'd say this 2 could come out. I can have 2 a's or an a come out and have 2 left over and no b's. So this simplified would be 2a cubed root 3a squared b squared. Now, we're going to rewrite this into its exponential form. Writing in an exponential form. Not difficult. What we have to realize, take the same stuff that's up underneath the radical, and we'll take the radicand, and I'm going to raise it to a power, to a fraction power. Okay? And the index is going to be my denominator. Oh my, that easy? Yes, it's really that easy. The index is the denominator. So, let's rewrite this in a form here. This was 2 cubed times 3 times a to the fifth times b squared. Let's use our exponent rules, which says I am going to distribute that 1/3 into each one of these exponents. So now I get 2 to the 3 over 3 times 3 to the 1 over 3 times a to the 5 over 3 times b to the 2 over 3. Now, we're just going to simplify our fractions. 3 over 3 is what? 3 over 3 is 1. So this is now 2 to the first power. My fraction can't simplify, so that's 3 to the 1/3. A does simplify. A to the 5/3 is really a to the 1 times a to the 2/3. Remember, 3 over 3 is the same thing as 1, and my b is to the 2/3. I'm going to take those things that have whole numbers, right? So this is now 2a, and what's left is 3 to the 1/3, a to the 2/3, and b to the 2/3. Oh, look. I want you to notice this. 3 to the 1/3, remember 1/3 is a root, radical 3, index 3, a to the 2/3, b to the 2/3. So I have just rewritten this, and I might even, if I just so felt like it, I could write it like this. And this is exactly the same thing that's underneath that radical. And remember, the denominator is my index. This is just an exercise in rewriting. That's all it is, and we can do computations much easier when they're fractions than they are trying to deal with the radicand. That's all. Give you a couple problems to do and come into class. Talk to you later. Bye.